Okay, so let's unpack this idea. Imagine your solar panels working not just on bright sunny days, but also when it's absolutely pouring rain.
Yeah, and that's not science fiction anymore, which is pretty amazing.
It really is. So today, we're doing a deep dive into this concept, rain-powered solar. We want to look at what it could mean for places with, really variable weather, like Bellevue, Nebraska, for instance.
Right, and we're basing this on some really interesting materials from Black Knight Power, a white paper, and some article excerpts they put out. Titles like Rain-Powered Solar Panels in Bellevue and Rain-Powered Solar, a Bellevue Climate Solution.
So our mission here is pretty clear. We want to help you understand how this emerging tech actually works.
And importantly, why it matters, what the potential impact could really be. We'll get into the heart of the system, these things called triboelectric nanogenerators, TANs for short.
TNGs, okay.
Yeah.
And they convert the kinetic energy from raindrops.
Exactly, the energy of them falling and hitting the panel.
So if these TANs are using friction from raindrops, what's the basic problem they're solving that, normal solar panels just can't handle?
Well, that's the key limitation, isn't it? You know how when a big storm hits, your solar production just tanks?
Yeah, it drops off completely sometimes.
Right. Conventional panels can produce next to nothing in heavy rain. And even on just cloudy days, you're only looking at maybe 10, perhaps 25% efficiency.
Not great if you need consistent power.
Not at all. But you canes,
Mhm.
think of them like tiny energy harvesters. It's basically friction-generating static electricity, like rubbing a balloon on your hair, but microscopic.
Okay, I get the analogy.
So as raindrops slide across this specially coated surface, that friction generates a small electric charge. Scientists over at Suzhou University in China, they've actually shown this works in the lab.
So capturing energy just from a raindrop sliding, but you said nano generators. That sounds really, really small. What kind of power are we actually talking about here per drop?
That's a fair question. And you're right, it's minimal per raindrop. We're talking picowatts.
Picowatts. That's
Yeah.
incredibly tiny, isn't it? A trillionth of a one.
It is extremely small. But, and this is the crucial part, it's not about one raindrop. It's about millions of raindrops hitting the panel surface over time.
Ah, so it's the cumulative effect, the scale.
Exactly. It all adds up. It provides meaningful supplemental power right when traditional solar is performing poorly or not at all. That's the continuous energy angle.
That at-scale idea really makes you think about where this would be most useful. And Bellevue, Nebraska comes back into focus.
Right. Their climate data shows they get, around 921 millimeters of precipitation a year on average?
Yeah, quite a bit. And August is usually the wettest, about 130 millimeters. But it's also unpredictable. They had one of the rainiest months ever recorded in Nebraska back in 2025.
So for them, having any kind of power generation during those wet periods, that's valuable. It addresses that inconsistency.
Okay, but what about the cost? Does adding this tech mess up the economics?
Well, that's definitely a consideration. Nebraska has relatively low electricity costs, which already stretches out the payback time for traditional solar.
Right, I saw that a typical 5-kilowatt system there costs around $11,000 before credits, and the return on investment is something like 22 years.
Which is quite long comparatively.
Yeah, 22 years feels like a long time to wait for payback. So how does rain power fit in? Does it make it better or worse?
That's the interesting calculation. Yes, adding TENGs, this newer tech, will almost certainly increase the initial installation cost. No doubt about that.
Okay, more expensive up front.
But the potential for actual year-round generation, harvesting energy from that 921 millimeters of rain over their, say, 75 rainy days, that could potentially shorten the ROI timeline.
Ah, because you're generating power on days when the old panels produce nothing.
Precisely. Even if it's modest power, for a typical Bellevue home, having consistent power during those increasingly wet springs or any rainy period reduces their reliance on the grid right when their solar would normally be offline.
So it's less about massive energy spikes and more about reliability, a steady trickle.
Exactly. It's about smoothing out the production curve and adding value during those downtimes, reducing grid dependence during storms.
Okay, so let's bring this all together then. We've got rain-powered solar, using these TENs, offering a way towards more continuous energy. It tackles that big weakness of traditional solar.
And it seems particularly relevant for places like Bellevue, where these unpredictable weather patterns seem to be becoming more common.
Right. So even though the tech is still developing and the energy per drop is small, the ability to generate something during wet weather definitely improves the whole value proposition for solar, doesn't it? Makes energy independence feel a bit more robust.
Absolutely. It makes you start to rethink things.
Which leads to a bigger question, I think. What does this kind of development mean for how we even define reliable energy? How might our expectations for power sources shift as global climate patterns keep changing?
That's the million-dollar question, isn't it? It challenges the old assumptions. Definitely something to keep a very close eye on as this technology matures.